Welcome again. Now start next topic, deduction of Coulomb's law. Deduction of Coulomb's law from Gauss theorem. So we have to now prove Coulomb's law by using Gauss theorem. So you know that this is the Coulomb's law, electrostatic force of attraction or repulsion between 2 point charges Q1 and Q2 is equal to 1 upon 4 by epsilon naught Q1 Q2 upon r square, where r is the distance between the 2 point charges. So starting from this concept that suppose we have 2 point charges separated by distance r. Suppose this is Q1 charge and this is Q2 charge separated by distance r. For this we have to use Gauss theorem. So you know that in the Gauss theorem we have studied about the Gaussian surface. So we will draw the Gaussian surface first. So considering this Q1 charge as the center and r be the radius of this Gaussian surface, we will draw a closed surface. We will draw a closed surface whose radius is r and Q1, that is the charge, lie at the center O, and this is known as Gaussian surface. This is what Gaussian surface. This is Gaussian surface. Now Q1 lies at the center of this Gaussian surface and Q2 lies on the surface of this Gaussian surface. So later on we will use this Q2. Firstly we will explain or we will study about the Q1. What is the role of Q1? Now with the help of Gauss theorem, what we will do? You know, in the Gauss theorem we are considering one small area element ds, or this is area vector ds, and this area vector is in outward direction. So outward direction represented by the unit vector n, and Q1 charge having its own electric field, and this electric field is outward. So this is the direction of electric field also. This is the direction of this electric field. E is the electric for this Q1 charge. So E is parallel to unit vector n. So theta is equal to 0 degree. So this concept we have used in the Gauss theorem. So by using Gauss theorem we have to prove Coulomb's law. So we know that according to Gauss theorem, surface integral of electric field is equal to Q upon epsilon naught. Since Q1 charge is enclosed, this Q1 charge is enclosed by this Gaussian surface, here we will write Q1. And this E ds can be written as E ds cos theta and integration of over the closed surface Q1 upon epsilon naught. So theta, that is equal to 0 degree. So we can write E ds whole integration Q1 upon epsilon naught. Now because electric field is constant over the Gaussian surface, you know that electric field is constant. So this is kept outside the integration Q1 epsilon naught. So E and area of this closed surface, that is 4 pi r square Q1 upon epsilon naught. So E is equal to 1 upon 4 pi. E is equal to 1 upon 4 pi epsilon naught Q1 upon r square. This is equation number 1. And you know that this is the electric field due to point charge at a distance r. So ABC, this Gaussian surface, at this distance r, at this distance r, this at this distance r, at this distance r, at every point on the Gaussian surface the selective field remain constant. So from this equation we have proved that at every point on the Gaussian surface electric field remain constant, electric field having spherical symmetry. This point we have proved. So now since Q2 charge lies on the Gaussian surface, Q2 lies on the Gaussian surface, so this Q2 charge will experience force due to this electric field. Due to this electric field, it will experience the force due to this electric field. That is given by equation number 1. It will experience the electrostatic force. This electrostatic force. So F is equal to Q2 E. We know that is from E is equal to F upon Q. This formula we have used. So Q2 charge, this Q2 charge here, this Q2 charge lies on the Gaussian surface. It will experience the electrostatic force because at this Gaussian surface electric field is a constant. So F is equal to Q2 E, and from equation number 1 we will put 1 upon 4 pi epsilon naught Q1 and this Q2 upon R square. So this is Coulomb's law. So we have learned that by using Coulomb's force we can prove Gauss theorem. This in the Gauss theorem we have studied and we have used there Coulomb's law. With the help of Coulomb's law we can prove Gauss theorem, and with the use of Gauss theorem we can prove Coulomb's law. So it means Coulomb's law and Gauss theorem complementary to each other. I think it's clear to all of you. Thank you.